Hello, this is Mr. Stein, and in this video, we're going to look at examples 3 and 4 for section 6.5, the slope point form of the equation for a linear function. After you're done this, you should be able to graph a linear function given in slope point form, write the equation of a line. If I'm given the slope and the point it goes through, convert from slope point form into slope intercept y equals mx plus b form. Now, if you remember, the slope point form is y minus y1 equals m over x times x minus x1. y1 is and x1 give us the location of a point on the graph. M is the slope. Notice that we have negative y1 becomes positive y1 in our point. Negative x1 becomes positive x1 in our point, and vice versa. The subtraction signs indicate that the sign will switch. All right, let's go look at examples 3 and 4. Example 3. The temperature in degrees Celsius is a linear function of the temperature in degrees Fahrenheit, F. The boiling point of water is 100 degrees Celsius and 212 degrees Fahrenheit. The freezing point of water is 0 degrees Celsius and 32 degrees Fahrenheit. Write a linear equation to represent this function. Use this equation to determine what happens, the temperature in degrees Celsius of which iron melts, 2795 Fahrenheit. All right. So what we have here is we have 2 points on a linear function. Our first point is at 100 degrees C, 212 Fahrenheit. Our second point is at 0 Celsius, 32 Fahrenheit. We have 2 points that make a line. We're going to build a graph for this. We're going to take a look at that graph. So I'm just quickly drawing an axis here. I'm going to call this Celsius and this Fahrenheit. Okay, our first point is at 100 Celsius, 212 Fahrenheit. So if it's at 100 Celsius, 212 Fahrenheit, it's about, let's say there, 100 Celsius, 212. Then at 0 Celsius, our second point is right here. It's 0 Celsius, 32 Fahrenheit. 0, 32. And the line goes through those two. Okay, so we are going to write the equation of this line. And we're going to use point slope form. First thing I need to do is I need to calculate slope. Slope is equal to, now here's what I'm going to do. I'm going to use the formula for this. y2 minus y1 all over x2 minus x1. All right, so we have to choose one of these to be 0.1 and 0.2. Now, I'm actually going to choose this one to be 0.1 because it's smaller numbers. It's farther to the left, and this one to be 0.2. y2 is 212. So 212, y1 is 32. x2 is 100 over 0. So our slope is going to be 212 take away 32, which is 180 divided by 100, which is equal to 9 over 5. Now, I should indicate that we don't really have y2 and y1. I shouldn't be using those. It really should be Fahrenheit 2 minus Fahrenheit 1 over Celsius 2 minus Celsius 1. I'm going to just erase that and show you. Should really be Fahrenheit 2 minus Fahrenheit 1 all over Celsius 2 minus Celsius 1. Okay, so this means there's 9 degrees Fahrenheit for every 5 degrees Celsius. All right, now let's take a look at our point slope form. Our point slope form looks like this. Y minus y1 equals mx minus x1. Now we're going to change this from y's and x's to Fahrenheits and Celsius. Fahrenheit minus Fahrenheit number 1 is equal to our slope times Celsius minus Celsius number 1. Now we know the slope is right here. It's 9 over 5. And we know a point right here. So let's put this stuff in. Fahrenheit minus 32. Notice how it is positive 32 here, so now it's negative 32 here. Equals 9 over 5 times Celsius minus 0. Right, we have 0 here, so it's 0 here. Now 0 is neither positive nor negative, so we just put 0 in. Now we simplify this. So we still have F minus 32 is equal to 9 over 5 times Celsius, right? We multiply this out, but 9 over 5 times 0 is just that. And then we get F is equal to 9 over 5 Celsius plus 32. There we go. We can see this is our F-intercept. It's not our Y-intercept, it's now our F-intercept. And look, right here on our graph, it is our F-intercept. That's not very easy to see right there. There's our F-intercept. Okay. So now use this equation to determine the temperature in which iron melts at. So we know a Fahrenheit, we're asked to figure out a Celsius. I'm out of space here, folks. So what I'm going to do is I'm just going to squeeze this in over here. Fahrenheit equals 9 over 5 C plus 32. Now we know that our Fahrenheit is 2795. First thing, take 32 away from both sides. I'm going to really zoom in here. Take 32 away from both sides. To get 2763 is equal to 9 over 5C. Now I'm going to get rid of the 5 in the denominator here by multiplying both sides by 5. So I times this side by 5. I times this side by 5. And that 5 is going to cancel out with that. And I do 2763 times 5. 13,815 is equal to 9C. Divide this side by 9. Divide this side by 9. To get C is equal to 1,535. All right, so in this question, we were given 2 points on a graph. From those 2 points, we were able to figure out the slope. Then because we had points and a slope, we were able to use this to figure out an equation for the line. You should be able to do all of this without having to graph it. All right, example number 4. Write an equation for the line that passes through S to -3 and is parallel to this line and is perpendicular to this line. Okay, so what we know here is we want a point that goes through, we want an equation for a line that goes through 2 and -3. We're going to have 2 lines. One that is parallel to this line, we're going to do that one in blue, and one that is perpendicular to this line. 3x plus 5. 3x plus 5 looks like this. Doesn't take much to graph that. Okay, so now we need a blue line that goes through this point and is parallel to that line. Well, what's the slope on this going to be? For letter A, our slope is going to be equal to 3, right? Because it has to be parallel to this line, so our slope is going to be 3. So what is the equation for this? Well, we use our formula. I'm going to start it a little bit over. Y minus y1 equals mx minus x1. So we know our slope is 3 because it's parallel to this black line. And we know one of our points, our y point is -3. So we have to put a positive 3 in here. And our x here is plus 2. So we're going to put a minus 2 in. Minus 2. Now we're going to simplify this. Y plus 3 is equal to 3x minus 6. Y is equal to 3x minus 9, right there. This is the equation for this blue line, and let's draw it on. The blue line would go like this, parallel, same slope. And right there we can see its y-intercept's at minus 9. Okay, so now we want one that's perpendicular. Letter B, it's perpendicular to this black line. Now the slope of the black line is 3. So the slope of a perpendicular line will be negative 1 over 3, the negative reciprocal. So the slope of this line is going to be negative 1 over 3. Now let's take a look at how that looks on the graph. So it's negative 1 over 3 right here. Starts at this point, negative 1 over 3. Go backwards, negative 1 over 3 right there. Right there. That is what this purple line will look like. It's perpendicular to the black line, and it is through the point 2 and negative 3. Now let's use our formula. Y minus y1 is equal to mx minus x1. We know that our y1 is negative 3, so we put in y plus 3 is equal to negative 1/3 x minus 2. Right, our x was plus 2 up here, so it becomes minus 2 down here. Now we work this out. Okay, we work this out and we get y plus 3 is equal to negative 1/3 x plus 2/3. Something's not quite jiving right with me right with this one. But let's keep going. All the math I'm doing seems to be correct. Then we take away 3 from both sides, and we get... Okay, never mind. It works out. I just confused myself, mixing up the y-intercept and the x-intercept. I'm good. The math is right. So we subtract 3 from both sides. So we get y is equal to negative 1/3 x subtract 2 1/3. Now 2 1/3 is 7/3. And if we look here at our y-intercept, right there, it's about 2 1/3 down, or 7/3. All right, so I hope this was helpful to you. Hope you understand the slope point form or point slope form.